Um, so um, I've been porting some of the GS code that I wrote some time ago to Rust and WebAssembly. Um, well, what I'm gonna be doing today is getting my GPU struct to work. Yeah, it's right here. This is the old code. Um, which I really like the way GS, like the way I figured out how to make this seamless in JavaScript. And I don't think it's gonna be um, as easy slash good looking as it is in GS, because Rust doesn't have proxies or getters and setters. So if you guys don't know, web GPU has a specific, well, all GPUs have a read memory in a specific layout, and I think GPU layout algorithm, I don't think it's called a algorithm. There's like some spec that defines what the layout should look like. I don't remember. Layout view struct layout. Um, Backing. Padding. Blah blah blah. Yeah, I don't remember what was. Oh yeah, it's this one. Yes. Um, this is the expected layout, at least for web GPU. I don't know how what kind of backing is needed for other GPU APIs, but I feel like it's gonna be shared between all of them. So I don't know. Maybe we can just use this crate instead of going with our own layout uniform. Blah blah blah. Given the following shaders of a uniform interface. Oh, this is actually good. Oh, this is exactly what I need. How do I send it though? How do I get? I don't know how I can get a vector boolean of 2. Oh yeah, this is perfect. This is perfect. I might. Oh yeah. So never mind. We won't be porting this. Just for reference, like, to give you some idea of how this worked. So GPU struct is basically more or less the same thing. Let's say, okay, this is my structure, and then it figures out how to lay it out. I don't know if it handles reordering and all that, but the code that I wrote works as follows. So you would say, like, okay, I need a GPU struct, new GPU struct, and then you give the name. So let's say this is like some, I don't know, what did they call it, point light. So let's say a point light, and it's a it has a position which is of type vec2. Oh yeah, never mind. Vec2, and then I don't know, let's say intensity is f32, and here you can specify, okay, can I reorder this? Because what happens is, let's say you have a vec3f and a f32. So if I say none in here, what's gonna happen is, well, in this yeah, in this situation, so the f32s are aligned to 4 bytes. So in the memory we'll have one spot taken, and then the vectors are aligned to 16 bytes. So what's gonna happen is we will have 4 spaces left over. So this is our f32. Then this is just wasted space, and then here we'll get the position. So this is intensity. It's gonna be here. And this is gonna be the position. It's gonna end up here. And if it's laid out like this, what's gonna happen is the position is gonna be here, because the zeroth position is aligned to anything, basically, I think. And then I gets packed in here, so we're not wasting this much space. Yeah, and but yeah, this is exactly what it's gonna look like. And pose Z. So this one's gonna be pose X, pose Y, and pose Z plus the intensity. That's gonna appear. So yeah, we're not wasting this much space. So what else this structure allowed me to do is basically, if we look behind the scenes, well, it's a lot of generated code, but what it does, it compiles the instance. So I did some measurement of different ways I could speed up the process of writing. So behind the scenes, this GPU struct has a array buffer. No, uint 32 array, and what happens is the position. Let's say here, like we used fast optimal, because it's very small, it can do. So the different kinds of arrangement, what it's gonna do behind the scenes, like it's gonna try, okay, if I arrange it like this, how much space is it gonna take? Then I'm gonna arrange it like this, and how much it's gonna take. But the more properties we add, the slower it gets to figure out. Well, it's what do we call it? It's not it's factorial. It grows with the factorial. So basically, if you have another one, let's say like I don't know, orientation or direction, which is a vec3f, then it has to try this situation, this situation, this situation, this situation, anyway, you get the idea. So once it has figured out which is the either the optimal or like a good way not to waste space. So here, like, no matter what we, ooh, never mind. So this one is this is gonna be the most optimal solution. So we are just wasting one float, which we are maybe not wasting. Well, no, we are wasting one float, which is not send, and it's zeroed out by default. That is going to be at the end of this vector. So these are packed 4 together, and this one is just right after that, because it becomes 16 byte alignment. Anyways, so this has a uint32 array behind the scenes. So if we take a look at the compile instance, what it does, we have like a private buffer that is stored, and also we have like a CPU buffer, which probably is not the best way of doing this. I think there is a way where we can basically map or share one buffer between the CPU and the GPU, and then yeah, we have like the device and like which binding group and which pipeline this instance, well, whatever instance we're creating is gonna be in. So this whole thing, basically compiling an instance. First of all, the name is not well. It's not very representative, but I wrote this. I didn't care much about it. This what it does, it creates a class. Yeah, so it's gonna create a class with whatever name we chose for the structure, and yeah, it creates the buffer and stores like some kind of information. But what this whole like thing gives us is that we get like a struct ctr or const, and now we can just do like can create new instances. So when I call new, I'm basically getting as an output, I get like a buffer, a uint 32 that is memory mapped. And the advantage on this is I'll just do this. Let's say somehow s is a return type second return type of new. Yeah, so like we created one because I don't have a device and all the other things that are needed to create one. So let's say like somehow you got access to one. What you get is those getters and setters behind the scenes, but what is good about them is that I can so direction, for example, is a vec3, so I have like all the nice autocompletion to access, let's say, the 0th element, and then if I set it to some value, what happens is this, like this code is what's gonna do is it's gonna take the array buffer that's behind, let's say, and it's aligned in this exact position. So let's say this is my direction. I'm gonna just, or I can use this. So let's say this is 1, 2, 3. Then we have 1 here. Then we have 1, 2, 3. 4, this one is unused. This is the how the layout is done behind the scenes, and this is my direction. This is I right here, and then and this is the position. So what this does is it's gonna take this, which is instantiated to zeros, and it's gonna put the 3 in here. And then there's some other kinds of nice things, which is like I can also say 1, 2, 3, and this also works. And this is exactly what's going to be written to the underlying array. So one other nice thing is that we're not what is flush? I can just check the type. There's like a flush function, which under the hood is gonna take whatever. It's gonna take this and pack it into the GPU, but writing to the GPU wastes. We don't want to be writing stuff like, let's say this thing hasn't changed from one frame to the other. We don't want to be writing to it. So there's a flag, which is, do we have the flag? Or maybe we always flush. Or maybe maybe I didn't add this. Get name. Yeah, never mind. Because I went through multiple iterations, and I feel like I did not add the dirty flag. So what is good about this also is that we can, because we're using getters and setters under the hood, after each modification, we can write down somewhere that says like, okay, this is like, let's say that there's a flag here also that is set at 0 in the beginning, and then after each write, what's gonna happen is like, oh yeah, now it's 1, and then we don't even do anything about it. It's 1, and then if I do s flush, what's the problem? Which is possibly undefined. Oh yeah. Once we flush this, I never know what was the oh, what was it? Question mark point question mark. Come on. Yeah. Anyways, so if once I flush this, what it means is that, okay, this has been updated. So what's on the GPU is the same as what's on the CPU, so it resets. And then if I call flush again, nothing happens basically, because we check this flag, and we know that, okay, we don't have to write anything. What's on the GPU is the same as what's on the CPU. So this is what was how we did things on the JavaScript side. And I was about to migrate this, but then I see that there is like this crate that seems interesting. Light color, instance uniform, blah blah blah. Yeah, so maybe we don't even need to care about this. Yeah, it's gonna. What? How do I get the packed version of this? That can be applied to a certain insurance protection component with blah blah. Initializes. But then how do I get for types that can be used as the element? So let's say I get the struct of this thing. I can just check which one do I use. This one, RPR. Market rate for types. Yeah, that's fine. Yeah, we'll automatically implement this and trade struct type where market rate. Okay, but I don't know what gets add. Is there something that like, how do I get uh the bytes out of this thing? Boolean. Maybe I can just check the GitHub. Do we have? Yeah, we have tests. So compile test. Expect invalid mode. Blah blah blah. Path buff. Debug test. Blah blah blah. What is this? I don't know. Repeating the same type twice. I don't um I don't see what does it do. Wait a second. So result type is compatible with the field. That's one for that then is compatible with the field. Blah blah blah. Example given the layout uniforms. Construct instance with the compatible layout. All of the field names match the block. That is not strictly necessary or preferred field type required. From wrapped. What else do we have? So what does it implement? Get an equality. We get debug. Constant new size, blah blah blah, for float, for vec, for unsafe. Well, that's the thing. Where is this? Does it have anything in it? Index for vec 4. B account value of 2 boolean values. Let value blah blah blah. I still can't figure out like how do I transform. So let's say like I have created this thing. How do I get out the whatever I want to send? Def mute mat. Maybe like one of those derefs. What do we get? But then I get what is target? It's an array. Anyways, I think I can just, or what I can do is just get this and figure out to let u8. It is probably a u8 that is needed or something. Between strings, main let uniforms, main uniforms, slice uniform as std. Oh yeah, so there is some, which weirdly enough I did not find it, but maybe what I can do is just search here for it's not a thing at all. So maybe it like just imaginated this or something. Convert the slice to evacuate, blah blah blah. Layout knowledge base creates you. We help us with the blah. Is it this one? I don't know if it's the same thing. Yeah. Anyways, I wanna check it on my side of GitHub, which log into before I commit to this. Let's see if there this is lying. Is the thing. I don't think I saw it anyway. Oh, it is a thing. Where did it come from though? Example cube lib. Okay, so we can just go with this. This was a lot of time wasted for no reason, so this can okay. I'm feeling bad for trying to remove this. This and this is useless. We are probably gonna need new file gpu struct.rs. Reload this for cargo. And what's wrong with you? I don't have it as dependency oh yeah. This also can fuck off, and let's add this. Let's say GPU struct. I'm still gonna fuck. I shouldn't have deleted this because I'm gonna need I am gonna need a macro for this because well it's gonna, let's anyways, let's just work on this. Mm. Mm, 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 mm. I'm just gonna move through this. So maybe, yeah, start working on the render part, and then as I advance, I'll see what I need to implement or not. So this is the I was gonna sketch out what the objective is. For now, it would be a Rust library, UI library. So what's gonna, these are the parts that I have more or less working. So we have one canvas in which we render text. This is a normal 2D canvas. So, and then we have another GPU canvas. This is web GPU canvas. And then so what the original render had, let me take this hold on. Okay, let's see, come on, oh, I have to do this, and this should be working now. So this is the full GS thing that we're migrating slowly to Rust. So what I have is so we have a web GPU canvas, and the structure that I went with is a render. So this is our render. So render basically holds pipelines. It has a list of pipelines inside. So a pipeline for the GPU is let's say that, like, different kinds of codes that you can switch to more or less quickly. So in the beginning we have like 0 pipelines. So each time we call add material, it's basically creating a pipeline for the glass material. And so what when we are creating a material, any material would take, for now, like a transform is the minimal thing that any material has to take. So this transform thing is basically the standard this kind of aligned structure that is going to be sent for each instance of this material. So we can have like different kinds of materials. Let's say we have glass material, then we have a blur, and we have like color. So each of those will get its own pipeline. So one for you and one for you. It's not shared, but anyways, you get the idea. So the pipeline is gonna be a different. So if you take, like, for example, the glass material, what's gonna happen is let's take this one. So what's gonna happen when we are drawing, so as soon as we add a quad, so a quad is basically 4 points on the screen that describe, okay, this is gonna be a thing that's gonna be rendered here. So let's say we have these 4 points here, And then we said that this quad here is gonna be of type glass. So for example, if you take color, to be able to create a color, we would need to get a transform. So all of them take a transform, but a transform is basically a matrix that would tell you, okay, so I have a unit quad that is of size 1 by 1. I applied a transform to it, which is gonna put it in like screen space. So it's gonna scale it up to whatever size and translate it and rotate and so on and so forth, so that it reaches the whatever you want. So this, think of it as basically as setting a width, a height, and rotation and translation. Anyways, so once we have drawn this thing, what happens next is it's gonna go through each pixel of this quad, and it's gonna run a shader that is provided per material, fragment shader, which is a piece of code that's gonna run for each pixel of that quad. So depending on how complex or simple the material is. So if you take color, what it does is it just returns the uniform. So each quad basically is gonna get, I don't know if you remember the buffer thing. So this is our color. I'm really bad at explaining, but anyways, this is our color. We have our uniforms, and we have our shader code, and that's it, more or less. Maybe like some textures and stuff that can be also mapped per so some of them would be mapped per material. So for one material, all quads of the same material would share some part of the data. Let's say this part of the data is going to be shared between them, and then each quad of this material would also have its own data. This is the uniforms part, which is unique per quad, no matter what the material is. So this is the transforms. I was, for some time, I tried figuring out if I could make it work with instantiation, which is faster, because what you're gonna do is like render all the quads of the same material in one go, but then layering them becomes very tricky. Anyway, so what's gonna happen is we're gonna get our uniforms, which is basically this. So for glass, we just have a color and a transform, which is not true, because I did not fully finish the glass, but this is what the glass looks like. So we have the width, the height, the radius of the box, which is this thing, this radius here that you see. Then we have like a refraction, so I can, if I make the refraction stronger, you can see. So this is basically, there are multiple things that are layered under on top of each other. There is some chromatic aberration, which is if I make this, let's say I'm gonna try and make it stronger. Let's make this 1.5, and what's gonna happen is like it's gonna, if you can see like wherever the blur is happening, the colors are pulled apart. So um, when light travels through glass, different wavelengths get uh, distorted more or less strongly depending on what color it is, basically. So this is what this is about. Um, anyway, so I did not expose all those parameters because this is just a test. But anyways, the main goal is to get the framing working, and yeah, I think I don't know if I'm gonna post this anyway. I've been blabbing a lot for no reason. Um, so yeah, I'm just gonna create the render thing and just start. Dot rs. Okay, I'm gonna go feed the cats and be back. So, no. Hello, if there is someone watching. Um, I'm working on a GPU renderer for the web. So I've been porting some parts. Um, let's see. Struct. Render. Struct render. Let's see. What we're gonna need is probably a device. GPU. Oh, I have to get it from somewhere. GPU. Wasm. GPU Wasm. My engine. What is it? No, it's sys. Yeah. So what do I need? Because the following create features to be activated. This IP is unstable and requires WebSys unstable APIs to be achieved as described in the Wasm Engine guide. It's common for process to implement part of the area while the situation implement area is still to be developed. So the web miner is stable. For this case, some changes for customers, blah blah blah. Typically, assignment to use for this example is within cargo. Yeah, I can just do this. Hopefully, will fix this whole thing. Can I just add it here? I'm gonna add this and then add this to my UI as a flag. Let's see. GPU. What is it? Why can't I find it? Add. What the fuck? Use WebSys GPU. It's not here. GPU. Maybe I have to add it to this thing in here. Come on. Build dependencies. I don't think I need this also. Come on. Cargo build. Could not compile. Obviously, could not compile. Just can get web GPU. I don't know why this is config this. How is this thing not working? By business work rates to explicitly within cargo. Oh, okay, never mind. So I probably have to create a new folder. Cargo. Maybe let me see if I can create it here and make it cargo and new file. What is it? Config. Yeah, and just let me use unstable APIs. It's fine. I don't mind. Come on. And GPU. Yes. Oh yeah. So we got this working. So what else do we need? So my renderer, the GS version at least. Oh yeah, so we need a canvas also. Canvas is gonna be a HTML canvas element. So eventually, I think what's gonna happen is that I'm gonna slowly remove those and make it more and more general. HTML canvas. HTML. Okay, that's how. And then CTA. And this is gonna be a canvas rendering context, but probably we'll have to add some other kind of feature. It's gonna be GPU rendering context. How is it called? So we have canvas rendering context 2D. So it should be some other. Come on, canvas rendering. No. GPU. How do I get the? Let me see. So let's say if I have implementation for renderer and then new fn and let's say we got some a GPU somehow, and GPU, or we get a canvas somehow, HTML canvas element C, and I don't think we need to own it. If I do c dot get context ID. Yeah, I don't know how to get the oh, it's GPU. Okay, never mind. Yeah, so this is the canvas and the context is gonna be this kind of context for some fucking reason. And this probably will need to have GPU canvas context. Yeah, this list is becoming really long. Anyway, So, and this is basically, we don't need this. So what else did we need in here? Mouse position, materials. Yeah, probably we'll have to have is GPU the same as GPU device? I don't know what is the difference in here. GPU device. GPU. So there is the GPU device. What's the following crate? So what is the difference between GPU device and GPU? Requires the following crate features. Get preferred canvas format. I don't understand what's the difference between this and this. Features, limits, adapter info, queue, lost. Oh yeah, so let's say like we will have GPU and new device. It's gonna be of this type, and this probably also will have to have like some yeah, they should have just put a full or something like this, like a flag for all the features. I don't know why you have to list them and then look at this. Anyways, let's see if we can create, and probably yeah, we'll either we always render it like higher pixel density than whatever, which is possible. I don't know if I can do this. So take a renderer of type T, and then every time I add a material, and I have like some sort of, yeah, so I have a T here and a T here probably, and then each time I add like a public function, fn add material. I'm just gonna take a math type. I don't even know if this is you can do stuff like this, K, and this is K, or it does work. So it takes like some, what is K? K is like whatever, and then it returns a render. Oh, but we don't have, does Rust have, because ideally what I should have, I could do would be like T and K, or some way of saying like, okay, that now I have returned, and this takes a self. It takes self, consumes it, and returns you a new instance of renderer, which is K plus T. So K plus T maybe is the thing. Explain it out on the trait, express trait, blah blah blah. Oh yeah, anyways. I'm going to, yeah, probably material should be like some sort of trait or something, and this is not needed, this also not needed, and let's go. So I'm gonna return self, and we're gonna create a new self of websys window GP. I don't know how you get it. Oh, we will need more than this because getting the GPU is not is a sync kind of thing. Do we have navigator GPU? I don't know. Let's see. GPU request adapter to owned. Wasm in crate. Blah blah blah. Does not help. How do I get a GPU though? Or maybe a device. Is it in device? GPU device. Destroy level lost. Set label to own into ABI. New. How can I get a device? What gives me a GPU device? Do I have navigator? Is it a thing? Websys navigator? Yeah. This is really becoming tedious. Okay. Let's say web is navigator active our displays get. How do I get the permissions, types, plugins, do not track, max touch point, mega probability connections, active. What is it called? Let me check in the GS version. So get preferred canvas, request device, request adapter. Oh yeah. So do I have GPU? Okay. GPU. How do I get disable feature? How do I get navigator then? Oh, so I can get it like this. Okay, so if I say window websys window or window navigator window unwrap navigator GPU unwrap let v. So this is my GPU. So what happens? So I get GPU, and I can do GPU request adapter. And this is a promise that I have to resolve. Await, and let's do a sync here. And I don't remember how to handle promises, so let's see. And just search here. Oh, it says promise resolve. So I have to do GS future. Let me get this, and then from this, and then I can await you, maybe. Yeah. And let adapter equals, and this I can unwrap, and adapter into, and save or whatever it was, did into unwrap, and this should be GPU adapter or some stuff like this. GPU adapter. Let's see if this thing can help. GPU adapter. Is it a thing? And no, it's not a thing. It's very tedious to work with the website. It is a good create, but the amount of features that you have to activate to actually do something. GPU adapter. Oh, yeah. So this needs to be PU adapter like this, and this like this. So we got our adapter, and so from the adapter I have to request a device. Request device. Is this also? This also is a promise. Let device equals this, and same thing. So we have to do GS future from this, and probably let device equals device. Oh, yeah, we did not. Await and unwrap, and then from the device I'm gonna make into and GPU device. Oh yeah, and unwrap also. So maybe this thing can just put it right here. I have to create more stuff, and same for this. Yeah. So we got the device. Once we have the device, I have to configure my context. But first we have to get a context. First, let's create the canvas. And to create the canvas, I have to do window document unwrap. Yeah, as let window equals window unwrap, and then replace this part with window. This is working great, and then here I can window document and probably also unwrap, and I just do this, let document equals this, and let body is gonna be document body unwrap. So we have all those things, and I'm gonna create my canvas. Let canvas equals document create element and canvas, and then probably unwrap. And then dynamically cast it to a canvas HTML canvas element, and then again unwrap. Okay, and then from the canvas, let ctx is gonna be canvas get what do we do? Yeah, init let's see construct where do I call in it? Here. Oh, this context, but then when do I this C? Okay, so I do create this and then I do get context, get context, and then for the context we have to provide this thing, and same thing, we unwrap, and probably I have to unwrap twice for some reason, and then dynamic into and say that this is gonna be GPU canvas context, and then unwrap again, and here we are. So we do have the context, we have this, and then let me get back to init. Yeah, and now I have to configure this. This, so ctx config. So configure is not a thing. Configure. Configure. Is this a thing? And probably. Oh yeah, so basically how it works is check GS or whatever TypeScript you have, and then you probably won't have the feature activated, so you go configure, and here we have to create a GPU configuration thing, and this is fine. So this is, yeah, this has to be a ampersand here, and what do we need for our it's struct literal syntax. How do I create one of these? Set device, get format, set format, blah 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 blah. So do I have to create it from what kind of object is this? What is this? I don't even know. Because it doesn't give me, like, okay, it's telling me it's a type, but I have no idea what the type looks like. Oh, I can create one. Okay, let's see if I can create it like this. So that's fine. And I do new. No. Um, mm, 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 mm. How is new not a thing then? Because I see it right here. Set device, mapping, get usage. Wait a second, it's right here, right? Unstable APIs, new public FN, and construct a new configuration. Decided required the following great features to be activated. Oh, okay. So I need this also. I'm gonna be adding a lot of stuff to this. Okay. Still does not help. So what do I need? I need a device. So this I have. Device, and I need a format, and this is gonna be easy because the format we get it from navigator. Let preferred format, but weirdly enough I don't have the alpha mode. It's fine. Navigator. Yeah, I should have taken it here. Let door equals window navigator unwrap. Oh, okay, so I don't even need it to be like this, so I can navigate here and get GPU preferred canvas format. Yeah, I can just do it like this also. So this is unneeded. Yes. And let's create a configuration thing. GPU canvas configuration. Let config canvas config equals this, and then I'm gonna say new, and we're gonna do device and then preferred format, and this probably also has to begin like this. No, like this. So it does eat the thing, and probably I have to do mute here so that I can do canvas config set set usage, set view format. What is this? How do I set the GPU canvas alpha mode? And I have no idea how to set this. GPU canvas alpha mode. Okay. Like I said, it is if you don't see something, you just have to go here and put it. Set how do I set the alpha mode then? Canvas alpha mode pre-multiplied. I don't know. Alpha mode. Set alpha mode, and so maybe this thing will allow me to, now that I have the alpha mode stuff, new set format usage as clone instance of because usually what happens is that you have anyways, it's fine. I'll just keep it as new. canvas alpha mode. Here I have to create a new alpha mode thingy. Import this, and oh, this is a new, so pre-multiplied. We did pre-multiplied, and weirdly enough, it doesn't have to be mutable for some reason. Can you see the amount of code that you have to go through to get this? And yeah, we forgot. So we have to canvas ctx configure and canvas config unwrap, or maybe I can just do this. I don't know if it's useful to. Well, let's make it break. At this point, yeah, we're just unwrapping everything. So I have to create a sampler. And mouse move, resize, and pixel ratio change. So I have to create this thing. I just don't like how let's add DPI. Do I need DPI? Oh, yeah. Let's do body, append child, and canvas. So this is gonna open our canvas, and now we are basically ready to draw stuff, more or less. But before, so I need a render loop. Let's so the to do is a render loop. And these two events. Oh yeah, and yeah, let's do this, the canvas, so that it's full size. Canvas set or no, it's style, then set property, and width this is gonna be 100%, and same for height. I don't know how expensive those unwraps are. Well, technically, like right now I don't care that much also, because this is a called once. So we got our render. I know that there are a lot of things that are missing. But let's do this. First of all, I'm gonna create on resize, fn on resize, and this is what we're gonna call on resize. and this is on Windows, so I'm gonna window add event listener with callback, and this is resize. And this I don't even remember how you create a listener. Let's create the self. So let renderer equals self. So yeah, now we have canvas, CTX, and then GPU and GPU device. Or this is device. Maybe what I can do, first of all, this thing can be renamed to device, and GPU probably I don't even need it. I'll just keep it for. And so this is what we return by the end of it. I just have to attach the events here. Attach events, resize, and then I have to check how that whole events situation was. Events. WebSockets, WebAudio, some of the program. I think it was here somewhere. Canvas, Julia set, WebAudio, WebGL, closures. But I don't want it to be a closure. Should I have a document? Should I have a window? Blah blah blah. Setup clicker. So what does setup clicker do? Get on by ID, num clicks equals 0, and then I create a closure from. And what do I move? What am I moving? I'm moving clicks. Let me see if I can. I probably would. Let's see. And this doesn't need fn. I don't need it to be fn mute. And let x. This is on resize. On resize. And can I do renderer on. Oh. So probably I don't even have to do it like this. Oh yeah, so first things first, the things that I have to make sure is that renderer is static, whatever. Make sure renderer is static. I don't know how to do this. I'll just make it simple for now. That's gonna be E. Actually don't need the event. And here I can do window. And that's the same thing also. There's like some story of forget. See comments inside setup clock above to why we use a forget. Normally we'd store the handle to later get dropped at the appropriate time, but for now we want it to be a global handler, so we use the forget method to drop it without invalidating the closure. So, oh, okay. So what I can do here is on resize, and it's gonna be a closure, and I have no idea what put here. Is there any way that a static lifetime closure is transferred size? And what do I get here? Can I? And do on resize, and I have to do into and some other stuff, I suppose. Into, no. And add event listener websys event listener. Yeah, I think I found it here somewhere. Huh. So I'm going to use the following code. So I have to wrap. I don't know what the fuck is this, but let's trust. Wrap. And let's do box, new. And then put this here. And as ref and check ref, blah blah blah. On resize. Oh yeah, this probably is not the best way to do this. And then I don't know why we need the box. What does box do? A pointer that type uniquely owns a heap allocation of type D. On resize, closure, I don't even know, let's say dynamic fn. Is this a thing? Yeah, it is a thing. Has type, which is not the clone. So, oh, yeah. I'm just gonna push you in here and then unwrap. This probably is gonna be really bad, by the way. This thing, I don't know when it's gonna be, like what's gonna happen with all this, but plus I have no idea why the fuck do I need the box. What is a type that uniquely owns a heap allocation of type T? Okay, and then what is the closure? Both closure and rust, well, which is trust closure. Closure is the primary way that a static lifetime closure is transferred from rust to GS closure. Currently required that the closure is created didn't have the static lifetime in rust for some reason. So the problem here is that anything that happens here, let's say like if I anything I reference here, all this is probably gonna be dropped. The only thing that's still gonna live is this. Well, for as long as it needs to. But let's see. So here, what I can do is do window inner. Oh. Yeah. And also I have, okay. Let me rename this to win. I'll still need where's my closure? Okay. So I have to do window, unwrap, inner width, and probably also unwrap, let W, let H, and then this as F64 and unwrap again. Unwrap and do the same thing for the height. And so here also I can do let wind, and this I can put it here and change this to wind. So yeah, the thing is that this basically what's gonna happen is as soon as this function is done. So oh yeah, two things. First of all, closure is like, although it just, I don't know how it works exactly under the hood, but just I just know that even if I reference stuff inside the closure, which I think what happens is that it's gonna think that all the things that are referenced inside have a static lifetime, meaning that they live as long as the closure itself. But in practice, what I've noticed is that referencing anything outside the closure is not good. Like you just get garbage. Anyways, so here also I'm gonna do wind and unwrap. So here we get our two things, and then I can do console log 2w into and h dot into, and probably I need to do this, and there we go. Let's test this out for now. Where's rasterizer? So maybe, well, it's fine. I'll just add the render. Yeah, and for some reason, how is this not? I have to do pop here, pop renderer, and then put renderer in here. And oh yeah, definitely I have to renderer. Let this equals new. Oh, I have to await this. myself in here, and weirdly enough, this has worked. So this, what this is supposed to do. First, let's see if I can build this cargo. What is it called? Hello world. Blah 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 blah. What's the magic? Wasm by engine create using console logs, models and files. I don't remember what was the magic. That's something like Wasm by engine. I'll just check. Wasm by engine web assembly. Yeah, this is the one I need. And yeah, this is the magic command I was looking for. It wasn't back for some reason. I thought it was. And also we have to go live, and UI example, and this probably is not gonna work because of yeah. Okay, here is what we got so far. But because I changed this thing, I don't know what this is. Yeah, I'll have to run this, and I feel like the have to add another thing here, like UI. I think UI slash package slash. Oh, come on. So it's at UI example. No, it's at UI package slash. I think I forgot the slash. So that is okay. All right. So hopefully, if I move this, oh yeah, but this. So what we have right now is a way to detect the screen resolution. Well, it's not exactly the screen resolution, but like almost detect screen resolution. And yeah. On resize, so I'll have to create another one of these this one is gonna be a little trickier. Let on the DPI change, and so let's do it like this. So I'm just gonna do more or less the same thing. Gonna do win get device pixel ratio, let DPI unwrap. Oh yeah, so this is already good. Oh yeah, I'm gonna try something. First of all, I just wanna see like if this. I still have let's say size or screen size, which is gonna be U64 U64. Is it U64 F64 F64? Why is technically useless to have a screen size, and let's say take this, put it here, and then put this width and height. Okay, and then here I'm gonna say, oh, this is not gonna work. In size equals width and height. Turn in the scope, not found in the inner. So the problem is this. I need renderer on resize. Can I create a closure new like an empty kind of thing? And then size is okay. So I'm gonna make this smooth. Okay, and then at the end here I'm gonna say render dot on resize equals on resize. Only long enough to show. Yeah, this is gonna be coercion requires that screen size is port for static. Yeah, I'll have to. Okay, I'm gonna stop streaming. I think I'm gonna call it a day. Well, call it a day. Yeah, more or less call it a day. Let's figure out how to make this work safely, more or less. Probably we'll have to like wrap it in a box or something so that it gets yeah. Anyways, thanks for watching. I don't know if I'm gonna keep this one properly, because the first hour was just nothing.